Okay, well, hello everybody, and thank you very much for joining this talk. The talk's based, as Lucy said, on a thematic collection on paper making, and most of the illustrations you will find do come from that collection, but I've added a few extra illustrations in places just to explain a few more details. It's a huge subject, and I can't cover every aspect of it, so I'm going to concentrate on the basic story of its history. I'm going to start with early writing materials, go on to the invention of paper, how that knowledge reached Europe, how paper was made, firstly by hand, and then how it was made by machine. Paper was invented around 2,000 years ago, but formal writing systems have been around for about 6,000 years. So people used other materials, and they used whatever was available locally to them. In the Near East, they used clay. Wet clay was impressed with a reed stylus, then either left out to dry or baked in a kiln. And really important documents could be baked, then enclosed in an outer clay envelope, which had to be broken to get at the message inside. Stone could be painted, scratched, or incised, and we see many examples from the Roman period. And of course in Egypt, where tombs were decorated and inscribed. And it is still used today, for instance, for tombstones and memorials. So we've got a cover there from Tombstone, Arizona from 1881. And then metal was often used for important records to stress the value of the item or to demonstrate the wealth of its owner. Various plants have been used. Wood is cheap, it's easy to prepare and write on, and it is particularly plentiful in Northern Europe, for instance, birch bark, which was much used in Russia. It could be left in its natural state, it could be polished, varnished, or lacquered, and that's bamboo which has been lacquered. Leaves were used, particularly in the Far East, particularly large palm leaves, as you can see, make a very good writing material. And papyrus, which is perhaps the most successful material after paper, was in use from at least 3000 BCE. The papyrus plant used to grow wild along the banks of the Nile, and the writing material was made from the pith of the stems of the plant. The Egyptians, and later the Romans who conquered Egypt, did try to keep it as a monopoly. Parchment was used in Africa, the Middle East, and Europe. And the term parchment is just a general term for an animal skin which has been prepared for writing, usually calf, goat, or sheepskin. It derives from the place named Pergamon, which is a place in Turkey, now called Bergama, where it was reputed to have been first developed in the 2nd century BCE. And the term vellum specifically refers to calfskin, which is a particularly fine form of writing material. The skin was prepared by soaking it and then putting it onto a stretching frame where it was scraped to remove the hair, and that's what's shown in this Ethiopian stamp here. Parchment became the standard writing material in Europe from the 2nd century AD, but using animal skins was expensive, and the sheer cost of parchment was one driver to adopt a cheaper material when it did become available. Paper was invented around 2,000 years ago by the Chinese, who hail it as one of what they call their 4 great inventions, by which they mean paper, printing, the compass, and gunpowder. And the invention is traditionally ascribed to Cai Lun, this chap here, but in fact he was the court official who first recorded the process in 104 AD, and it certainly does predate that. Recent archaeological finds put it to somewhere in the 1st century BCE. The use of paper was immediately recognised, not least because it was a lot cheaper than silk, which had been the Chinese existing favoured writing material. But it took a long time for the knowledge of papermaking to spread. It reached Korea and Japan in around 600, and then slowly went along the Silk Route. It reached Samarkand. Samarkand was the first place it went, where it was picked up by the Arabs. The Arabs took it all the way along the Silk Route. It reached Baghdad, which became a major papermaking centre from around 793. It reached Cairo from around 900. and then Fez from 1100. And it was from Fez that the information was carried into Europe. Spain was the first European country to make paper, and the knowledge had been brought there by the Arabs who ruled it in the early medieval period. The first mention of paper being made in Spain was in 1056 in Xàtiva, which is on the river Albaida. And this stained glass window illustration here in this souvenir sheet actually stands in the main stairway of a paper-making factory in Burgos, and it shows the main parts of the process of making paper by hand. And it's a building that now belongs to the Spanish National Mint. Paper had been known about in Italy since the Arabic occupation of Sicily in the 10th century, but it wasn't manufactured there until after they'd left. The earliest documented mill was at Fabriano, which is in central Italy, and that's known from a document dated in 1283. And it did become a paper-making centre by the 14th century. Fabriano had at least 40 paper mills. Inventions get developed when there's a need for them. One of the earliest demands for a cheap writing material was record keeping, so it's not surprising that Italy was an early adopter of paper. Modern banking started in medieval Italy, particularly in the affluent cities of Florence, Venice, and Genoa, and one of the biggest was the Medici Bank, established by Giovanni Medici in 1397. And here we have a letter from the Medici family from 1459. The knowledge slowly spread to most countries in Europe, and I've just picked out a few of them. Paper had been used in France for at least 100 years before it was made there. Some of it was imported from Spain and Italy, and some imported into Marseille from Syria. And paper was being made in the Auvergne area of France, at least from the 1340s. Perhaps the most famous of French paper makers, although for a completely different reason, were the Montgolfier brothers, Joseph and Etienne. They were born into a family of owners of a paper mill in Annonay in the Auvergne. And when they started experimenting with early ballooning, they lined their first trial balloon with 3 layers of thin paper underneath sackcloth, which sounds to me fairly terrifying, but they survived. And that company actually still trades today as Casson et Montgolfier. The first mill in Germany was built in 1390 by Ullmann Stromer outside the gates of Nuremberg, and that employed Italian paper makers. And this postmark design here is based on an illustration from the Nuremberg Chronicle of 1493, showing a paper mill outside the city gates. It's not really surprising it was located outside the main town. Mills were notoriously noisy and smelly, and you really didn't want one close by residential areas. As I said, paper production started in Germany in 1390, but the really big impetus for the demand for paper was the invention of printing by Johann Gutenberg in the 1450s. Instead of handwriting one book at a time, suddenly hundreds were being produced at once. And the world's first book trade fair was the Frankfurt Book Trade, which had been held almost continually since 1454, and which in the early days featured paper makers and printers. And by the 17th century, Frankfurt and Strasbourg particularly were centres of the European paper trade. The first paper mill in England was founded by John Tate near Hertford. It's not known exactly when, but probably in the 1480s. Printing had been introduced into England by William Caxton in 1476, and Tate is known to have supplied paper to Caxton's successor. A few mills are known from the mid to late 1500s, including that funded by Sir Thomas Gresham at Osterley in Middlesex about 1574. But the first really successful mill in England was owned by the German-born John Spillman, who was crown jeweller to Queen Elizabeth I and King James I. And he opened a mill in Dartford in Kent in around 1588. And he imported workers from Germany to operate it. But papermaking was very small-scale trade in the 16th and 17th centuries. There were 41 mills in 1601, and by 1700 that had only risen to 116. It wasn't really until the 18th century that England became a major paper producer. All the countries did eventually become exporters, but most countries in Europe had their own paper trade, but they were very small scale and largely relied on imports. And I've just got a few examples here from Northern Europe. Denmark's first mill wasn't a commercial one, and it didn't develop its own paper industry until the second half of the 18th century. Finland, Sweden, and also Norway started building mills in the 17th century, but it wasn't until machine-made paper started that both became important producers. The Dutch Republic imported paper, initially from Switzerland and Germany, and later from France, but unlike other countries on this page, it did begin to produce enough to become a major exporter itself from the end of the 17th century. So I'm going to move on now to how paper was made, and made by hand. I'm going to start with a look at the raw materials. Machine-made paper, which I'll come on to, it was mostly wood pulp, but made by hand was made from different materials. Paper's made from broken down cellulose fibres, so it can be made from all sorts of raw materials. So makers used whatever resources were plentiful in their area. So if we go back to China, where it all started, earliest Chinese paper was made from silk rags, it was made from mulberry leaves, and later on it was made from bamboo. And right from the start, the first choice of European paper makers was linen, which they obtained from buying old rags, which they ground down to fibres. And it's the fibres of the flax plant from which linen is made, which gave particular strength to the paper pulp. I said that mills were smelly places, and this is one reason why. When the rags arrived at the mill, they had to be washed several times until they were clean. And this was a particularly unsavoury job, since the rags started out as clothing and would have been completely filthy by the time they were good only for the mills. And it wasn't only dirty, it was dangerous, since the rags often carried diseases. And demand regularly outstripped supply everywhere. In England, for instance, an Act of Parliament was passed in 1666, requiring burial shrouds to be made of wool, not linen, specifically to protect the paper trade. And the import of rags for linen in England rose from 193 tonnes in 1725 to 3,404 tonnes in 1800. The use of cotton did help alleviate these problems. Supplies of cotton increased after 1780, when inventions which led to large cotton mills being built, including, for instance, the Crompton spinning mule, meant the growth of cotton mills and hence much more cotton waste available for the paper trade. It's the fibres in cotton produce bulk and opacity, and also a softness to the paper and a whiteness, which made cotton-based paper much in demand from artists and printmakers, including, for instance, Turner. Until the late 18th century, all Western paper was made from linen or cotton, but as I've said, increasing demand for paper meant shortages of raw materials, and experiments were made with alternative materials. But the aim really was to find cheaper, more abundant substances. The demand was for speed and low cost rather than quality. So if we look at some of these examples, originally obtained from sacking, jute contains about 60% cellulose and can be used. Hemp was used. It was obtained originally by unpicking old rope and sails, hence the English expression money for old rope. But its brown colour does make it difficult to bleach. Experiments were made with straw. It was little used since it made very poor quality, which was difficult to bleach. And this North Vietnam block of stamps here shows just how yellow the paper would have been. And also it's actually quite rough to the touch. The most successful material was esparto, and that did become widely used. For instance, to print the Illustrated London News in the 19th century. but it too needed a lot of bleaching. And of course, it all had to be exported, since esparto is native to Spain, Portugal, and North Africa. But wherever paper was made and whatever it was made from, the basic process of making it was the same. The material was cleaned, then ground down by beaters until the fibers were separated into individual filaments. These were transferred to a vat and intermixed with water, and that's what you can see happening. There's the vat there. A mould to make the sheet of paper was dipped into the vat, and some of the mixture, which is properly called stuff, was lifted out. And the skill of the vat man was to lift the correct amount of stuff and give the mould a shake, which settled the fibers evenly. He then passed the mould to the coucher to flip it over, which is what's happening here, and lay each sheet between felts. And then a pile of about 20 felts would be put in a screw press to drain out the water. These sheets were then sized, dried again. That's illustrations from the way it was done in the West. But if you look at these stamps from the East, from commemorating early paper making in the East, you'll find actually the process is exactly the same. There they are beating the pulp, and there they are lifting the mould into the vat. So the process virtually didn't change. You needed a power supply to drive the machinery, which pulverized the raw material, and it beat the fibers, as I say, to split and grind them, turn them into the pulp. So before industrialization, the power source was water. Early mills used wooden beaters, and you can see those here. They were large trip hammers falling into stone troughs, which is why mills were so noisy. In the 17th century, they were replaced by the Hollander machine that had a rotating axle fitted with metal blades, which circulated the softened rags around this oval tank, grinding them to pulp. Paper mills weren't necessarily purpose-built. They could be converted from other mills for other purposes, using existing equipment, so various types of water wheel would have been used. It's the mould, which I've talked about, which produces either laid or wove paper, which of course are stamp collectors we all know about. Early moulds were made of thin wires along the longer length of the mould. They were called the laid wires, and they were interwoven with heavy wires running across. These were called the chain wires, and they kept everything in place. All early paper is laid paper. Wove paper was invented much later by James Whatman, who started manufacturing at a Turkey mill in Kent in the 1750s. And there's a Whatman watermark, a somewhat later Whatman watermark. It's made, wove paper is made from a mould with a fine wire mesh omitting the chain wires, making it a much smoother paper. And the appearance of the edge of each sheet is also due to the mould. The wooden frame you can see here was called a decal, and some of the paper slurry passed under the decal, forming an irregular thin edge. And you can see that here on this block of GB penny reds made on handmade paper, where this edge of the sheet is quite crinkly. This was paper made at Rush Mills. And it's the mould that held the watermark. The design was made by thin wires twisted into shape and sewn on the top surface of the mould by even thinner wire. So as the mould was lifted out of the vat, the water drained away, leaving a thinner layer of fibres over the watermark than the rest of the mould, which you can see here on the mould for laid paper. So there's your chain wires and there's your watermark sewn on top. So if you hold the sheet up to the light, where the paper is thinner, they've got a thinner density, the watermark will show up. The original designs were simple shapes, limited by the pliability of the wires used. They were crosses, ovals, circles, triangles, but over time they became a lot more complicated. They had devices such as tools, animals, plants, religious symbols, even human figures, as you can see here, this splendidly mustachioed crowned head within an ornate body. Within a very short time of the invention of the watermark, they became standard, and countries that started making their own paper always included them, but no one knows precisely why watermarks were invented, but they did soon find some practical uses. They became a trademark, possibly from very early on, which signified the work of an individual paper maker and later that of a mill. Merchants buying paper wanted some form of identification in order to check which of their paper supplies sold well. The watermark should have been a guarantee of standards, but rival mills soon tried to copy the marks of mills known for their quality in order to pass off the paper as their own, so it didn't really work. In a mill which owned a range of molds, it was also a quick form of identification. The vatman usually worked with 2 molds at once in order to speed up the process, so the molds had to be matched pairs, and this was a quick way of making sure they were. And the mold also dictated the size of the paper, and differences could be quite small and not immediately obvious to the eye. So the watermark was universally adopted to indicate size. Foolscap, for instance, which is 16.5 by 13.25 inches, was first documented in 1479, and it used the watermark of the jester's or the fool's cap, hence the name. It was replaced in Britain in the 18th century by the figure of Britannia to indicate foolscap. But there were numerous Old English paper sizes. And sometimes there was a legal requirement for a watermark. A French law of 1582, for instance, required that all paper should carry the mill name so that excise duty could be charged. And in Britain, an Act of 1794 required that a date be used as a watermark for taxation purposes. It didn't have to be the date of manufacture, it could still be 1794, which can sometimes cause confusion, but you see an example there of a mill name and the date there. Papermaking changed completely once it was made by machine. The first patent for a machine-made paper was granted to a Frenchman, Louis-Nicolas Robert, in 1797. But he didn't have the money to finance the development of his ideas. His patent was sold on and eventually acquired by John Gamble, who applied for an English patent for the invention of a machinery for making paper on the 20th of October, 1801, patent 2487. Gamble was introduced to wholesale stationers, Henry and Celie Fourdrinier, and they saw the potential and they financed development by employing an engineer, Brown Donkin, to build a working machine at Frogmore Mill near Hemel Hempstead in Hertfordshire in England. It did prove a success, but the brothers failed to patent the design properly. Other companies simply sold the idea, and eventually the brothers were declared bankrupt. But they did receive lasting recognition in that to this day, even now, modern machines are still called a Fourdrinier. As you saw, paper had been made by hand in individual sheets, but the principle of Fourdrinier is that it's made in a continual roll, which came to be known as the endless web. And this schematic diagram of the first part of an early 19th century Fourdrinier shows what's called the wet end. And it consisted of a moving belt of wire mesh over which the stock was poured. So the stock was poured behind the head box here. It was carried along this mesh. It then went on further, which I haven't shown here, but that belt would turn around, return, and then just go round in a long continual rotation. And as the belt traveled, the water drained away from the mesh, leaving a continual web of fibers, which were pressed by a series of rollers and felts further on here to remove the remaining water. And in later developments, the resulting roll of paper was then dried with steam heated cylinders and finally calendared. And as the Fourdrinier machine was being developed and improved, so other inventions in the Industrial Revolution led to improvements in the way mills operated. Work by James Watt and Robert Stephenson, for instance, on improving steam power paved the way for steam-driven mills. And water turbines were introduced in some mills in the later 19th century. So we've got an example here of a steam-driven mill from Germany. And good transport links were absolutely vital for the mills, even in the early days, and even more so once you had machine-made paper and you had a lot of output. You needed machinery to transport, you needed transport to move the mill machinery, the raw materials, and then eventually, of course, the finished product. And handmade paper was originally transported by road, or in a few cases by canal. But with the boom in canal building in the late 18th, early 19th centuries, it became a fairly standard way, where possible, where you had it, of transporting what was very heavy and bulky items. This one is a rather earlier item. This, as it says, was carried from Antwerp to Brussels and actually endorsed down here per ship post. What they actually meant was per canal post. I was rather pleased to get that one. Railways were faster, of course, and they carried greater bulk, but they didn't immediately take all the mill goods. In many places, canal and rail were used simultaneously in the 19th century. Railways could open up new areas to industrialization, and you've got an example here from Romania, where a railway was opened connecting Romania and Transylvania, and because the transport was there, in a wooded area, they founded a paper mill in the area. And you've got an example here from a German cover showing a railway station place name, which was derived from the local mill. And rail was also used within large mill sites. On a really big industrial complex, you needed to move goods and things around, and they had their own narrow gauge railways. And one of them has been commemorated here. The steam train has been commemorated here. Industrial production, I'm sure you can imagine, put a huge strain on rag supplies. For instance, in 1850, the Times newspaper was using 7.5 tons of rags for one day's printing of 42,000 copies. And this, of course, was quite unsustainable. So there was plenty of interest in finding alternative raw materials. In 1844, Charles Fennerty invented a wood pulp process for paper making in Canada, and it became widely used for making newsprint. About 95% of the volume of a typical softwood, such as balsam fir, larch, and spruce, consists of fibre suitable for paper making. So for Canada and Northern Europe, particularly rich in this raw material, that introduced a whole new industry for them. But wood does need treatment to produce good quality paper, and there are specific terms for each treatment. The most basic of them is mechanical wood pulp, and that uses all the wood except the bark. So lignin and other substances which can cause paper to discolor and crumble are not removed. And it produces poor quality paper which quickly deteriorates. Newsprint, which is the name for newspapers, has traditionally been made from mechanical wood pulp. And as you know, you will remember when we used to buy newspapers, how quickly they would turn brown. Better quality paper requires the pulp to be treated to remove impurities. And the term chemical wood pulp, which is sometimes called by a complete misnomer wood-free paper, refers to pulp which has been boiled with chemicals in order to remove its unwanted constituents. The soda process was patented in 1854, and that involves boiling wood chips for 8 to 10 hours in a caustic alkali at high temperatures. The first chemical wood pulp mill in Canada was built at Windsor Mills, Quebec, using the soda process. In 1872, Carl Ekman, manager of the Bergvik mill in Sweden, invented a process for bleaching wood pulp with a sulfite solution, which produced a very good quality, clean white pulp. And this stamp shows a drawing of the first industrial digester based on his work. And that Bergvik mill was still in production in 1948 when this cover was sent. Right from the early days, mills were often dominated by the local area, and that can be sometimes seen in some examples here, for instance. Papiamula village, which is in the canton of Bern, was named after its first paper mill, which was built in 1466. And a similar example of a place name being derived from its major industry is Paper Mill Village in New Hampshire, named after a mill that had been built there in 1793. The place is now called New Alstead. And moving on a few more years, industrialization could have a heavy impact on a town. As an example, the town of Grand Falls was established specifically as a company town and financed by the newspaper magnate Alfred Harmsworth, Baron Northcliffe. He formed the Anglo-Newfoundland Development Company, which built its first mill there in 1909, specifically for the manufacture of newsprint. And in its early days, only employees of the mill, workers from relevant private businesses, were permitted to live in Grand Falls. Large-scale production, international trade, all led to standardization, and there was a campaign, particularly in Europe during the 20th century, to move to metric sizes. So these two examples show campaigning for metrication. And standard paper sizes today are defined by ISO 216, which is based on the German DIN 476 standard. So the way it works is that the basic A0 size has an area of 1 square meter, and all succeeding sizes are scaled down from this. So if you fold a sheet of A0 in half, it gives you A1, fold that in half, it gives you A2, so on and so on. And you can see here, you've got that's outer is A2, that is A3, A4, and so on downwards. Of particular interest to the stamp collector, of course, is the watermark. So I'm just going to spend a couple of minutes looking at that. And as you know, with stamps, the watermark's made by the dandy roll. This consisted of a metal roller covered in wired gauze on which the watermark has been affixed. It was first patented by John and Christopher Phipps in London in 1825, and the firm of John Marshall went into commercial production of dandy rolls a year later. These early dandy roll watermarks were little more than imitation chain and laid lines, but in 1839, William Johnson, working at his mill at St Mary Cray in Kent in England, patented a system for, I quote, affixing letters, figures, or devices upon a revolving axis known by the name of the dandy roll. And much later on, actually, the Johnson Company supplied paper for a number of stamp issues. So these pictures show you how the watermark's made on the dandy roll. Originally, the designs were sewn onto the gauze, but later on they were soldered on, as you can see here. And then from the 20th century, the rolls were made by electrotyping. And as in handmade paper, the fibres are going to be thinner in the roll where the watermark is. And very occasionally that can cause issues. The Edward VIII definitive series used this watermark shown here, E8R. Now this was a change from previous reigns, which had always used Roman numbering, so that, for instance, the George V stamps had GV. But the concern here was not only that EV111 was too wide for the stamp, but it would actually make the paper thin out too much, so it caused a change of design. And while normally the papers will be thinner, there are exceptions. The first issues of Russia in 1858 and Tuva in 1926. Here the dandy roll was incised rather than wires added, and so the watermark area is thicker than the rest of the paper and it appears opaque. And sometimes specialist catalogues will list damaged watermarks where parts of the watermark have become detached from the dandy roll. Each part of them is called a bit. And it seems to have been a particular problem with GB George V definitives with the symbol cipher watermark. And this example, I don't know if you can see it on your screens, but that's the full watermark with GVR with a crown over the top. And on the left-hand stamp, that crown is missing. It's become detached. And the Fourdrinier itself occasionally throws up varieties which can be of interest to stamp collectors. Some specialist catalogues refer to stitch watermarks, and that's where the wire mesh is stitched together on the Fourdrinier to form a continual belt. So of course it's a bit thicker, and it can sometimes create a mark in the paper, and you can see that along here on that block there. And then calendaring, which was the final part of the paper making process, it's the part that gives the paper its finish, can occasionally go wrong. And you can see this block across here. If you follow that line down there, that part of the stamp is much paler and it's got a sort of ghost appearance. And it's where the calendaring has failed there for some reason. And that's resulted in poor adhesion of the printing ink, which is very noticeable to the naked eye. Most paper today is manufactured in an integrated pulp and paper mill, as shown in this 1986 Norway miniature sheet, where every process from preparing the wood, treating the fibres with chemicals and dyes, right through to the finished rolls of paper are done in one automated process, although it does still use the principle of a Fourdrinier machine. And the Canadian stamp from 1956 shows a man completely dwarfed by the machine, but by the 21st century, machines have grown even larger. A modern machine, it can be 9 meters high, it can be 100 meters long, completely computer controlled, and you won't see human figures anywhere near it these days. But I'm going to finish this talk with an 18th century ditty about paper, which is much quoted in any book on the subject. Rags make paper, paper makes money, money makes banks, banks make loans, loans make beggars, beggars make rags. Well, really, nothing's changed. Thank you very much.